Welcome back for one final day of Unit 5 and one final day of Term 2. Today we're going to really pull a lot of ideas from this unit together and end with being able to solve random polynomial equations that we previously wouldn't have been able to solve. To get us started though, we're going to take a look at this thing called the integer root theorem. And this is a theorem that tells us if any of our solutions happen to be integers, what will those solutions be? Here's what this says. In a polynomial equation, the only possible integer solutions are positive or negative factors of the constant. In a polynomial equation, the only possible integer solutions are positive or negative factors of the constant. So here's what I mean by that. In this example over here, we know there are going to be three solutions. According to this integer root theorem, if any of the solutions happen to be integers, they're going to be positive or negative factors of 2. So my possible integer solutions would be plus or minus 1 and plus or minus 2. Now, we already said there have to be 3 answers. I have 4 answers over here. These are not all actually solutions. These are just the possibilities that happen to be integers. 1 could be an answer. Negative 1 could be an answer. 2 could be an answer. Negative 2 could be an answer. I know, though, that 5 could not be an answer because that's not included in this list. Negative 8 could not be an answer because it's not included in this list. In the next one, x cubed minus 2x squared minus 5x plus 10. The possible integer solutions will be positive or negative factors of 10. So plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Again, these are not all actual solutions. There's no way these 8 numbers would be actual solutions. There are only 3 solutions total. These are just the possible integer solutions. A few comments that I'd like to make. First of all, like I've been saying, these are not all actual solutions, just possibilities. These are not all actual solutions, just possibilities. There could be other solutions besides what's in this list: irrational numbers and complex numbers. There could be other solutions. Irrational numbers and complex numbers. All this theorem is saying is if any of the solutions are integers, they'll be in that list. They must be plus or minus factors of the constant. All this says is if any of the solutions are integers, they must be positive or negative factors of the constant. Please take a moment and make sure all of this is in your notes. So we're now going to see how to use this combined with other tools from this unit to be able to solve some polynomial equations we previously couldn't have solved. I'm on page 33. I want to solve this polynomial equation. Step number 1. How many solutions is that equation going to have? There should be 3 solutions. I'm going to start by just stating there will be 3 solutions. We'll deal with some in a moment that have more. Next thing I want to do is I want to find all the possible integer solutions. Find all the possible integer solutions. And remember, to do that, all we need to do, plus or minus factors of the constant. In this case, looking at 1, that means my possible integer solutions are 1 and -1. What I'm ultimately going for with trying to solve something like this is you know how to solve an equation like this. If I tell you an answer, that's what we did yesterday in section 5.7. If we could just figure out one answer, then we can do what we did yesterday. And we have 2 possibilities that could be answers, 1 and -1. I just need to figure out if any of these are actually solutions. I could certainly go and plug in 1, see if it makes it equal 0, or plug in -1, see if it makes things equal to 0. But if I have like a whole lot of possibilities, that's going to take a really long time. I could also use synthetic substitution to plug these in and see if I get a 0 remainder, but that's also going to take a while if I have a lot of options. What we're going to do to figure out if any of these are actual solutions is we're going to go back to section 5.5 where we looked at solving by graphing. I'm going to get one solution solving by graphing. Get one solution by solving by graphing, and I'll remind you exactly how that works in a moment. Get one solution by solving by graphing. Okay, so what I'm going to do, I'm going to go to the graphing calculator. Remember how we do this is we graph the function we're looking at. I hope you can see that. Maybe if I move it over here, we can see it. I'm going to graph the function that I have, so x cubed minus 3x squared minus 3x plus 1, and I want to find my x-intercepts. I'll set my viewing window at -10, 10, 1, -10, 10, 1. You know what, before I go on, I think I need to make this video pause. You need to go get your graphing calculator out, and if you don't have a graphing calculator, you need to be using the Chrome extension. Take a moment, get the calculator ready. So again, I'm going to type it into y equals. I'm going to set my window at -10, 10, 1, -10, 10, 1, and graph it. And I've got it. And I see 3 x-intercepts. Well, let me go try to find them. Second, calculate 0. Let's start with the one furthest to the right. Furthest to the right is giving me, okay, so I'm getting about 3.732. Yeah, I don't actually care about that one. That would have come from maybe like 1 plus square root of 7. I don't know, I'm just making things up here. And I want to try to get the exact answer, not the decimal. I think I need to remind myself what I was trying to do here. I wanted to figure out if any of these are actual solutions. So will this graph have an x-intercept at either 1 or -1? Looks to me like it could have an x-intercept at -1. Let me go check it though. Second, calculate 0. I'm going to go try to find that first x-intercept. And yeah, I'm getting x equals -1. X equals -1 is the option from this list that was actually a solution. So I know x equals -1 is a solution. Well, now that we have a solution, we do exactly what we did yesterday. We're going to divide by the factor that gives that solution. Divide by the factor that gives that solution. And then proceed as we did yesterday. How about proceed as before? And by before, I mean in section 5.7. So I'm going to go divide by the factor that gives that solution. Wait till it focuses. Then I'll do what I did yesterday, where I gave you a solution and you found the other ones. -1 in the box. 1, -3, -3, 1. Down 1, up -1, down -4, up 4, down 1, up -1, down 0. So I've got a factor of x plus 1 and a quotient of x squared minus 4x plus 1. If we were to FOIL these things out, yeah, I'd get the original thing back. One of my answers is x equals -1. Of course it is. That's how I created that factor in the first place. And as for the other ones, well, I need to use the quadratic formula to solve here, and I'm going to get the exact answers for those decimal places where that parabola was crossing the x-axis, where I wanted exact answers rather than decimals. Take a moment and go use your quadratic formula on x squared minus 4x plus 1 equals 0. X equals -b, 4 plus or minus square root of b squared, -4 squared, minus 4 times a times c, all over 2a. X equals 4 plus or minus square root of 16 minus 4 over 2. 4 plus or minus root 12 over 2. 4 plus or minus root 4 times 3 over 2. 4 plus or minus 2 root 3 over 2. So why don't I separate my fraction? 4 over 2 plus or minus, I'm off the screen, sorry. 4 over 2 plus or minus 2 root 3 over 2. I'm going to end with final answers of -1 and then 2 plus or minus, 2 plus or minus root 3. -1, 2 plus root 3, 2 minus root 3. And if we actually got decimals for these, we would see those decimals would match up with the decimal x-intercepts from solving by graphing. Make sure this is all in your notes, and then we're just going to look at 3 more examples of these things. Okay, so next. Letter A on the next page. How many solutions is that equation going to have? I hope you said 3 solutions. I need to get my positive and negative factors of 4. So plus or minus 1, plus or minus 2, plus or minus 4 are the possible integer solutions. I'd like to see if you can solve by graphing to figure out which of these are actual solutions. And actually, when you're done, send in the actual solution to Edpuzzle. Let's see here. Okay. X to the third minus 5x squared plus 5x minus 4. Start with that window. I may change it if I have to. Oh, I'm not going to have to. Oh, there's actually only one x-intercept. I hope it's one of the numbers on the list, otherwise I'm in trouble. Looks like it's going to be 4, but let me just make sure. Yeah, x equals 4, possible integer solution. Not possible integer solution, actual integer solution. By the way, I don't see any other x-intercepts of this, which means I've got to get 3 answers, though. I just have one that's 4. The other ones, if I'm not seeing x-intercepts, are going to end up giving me complex number solutions, because those would not be places where the the cubic function crosses the x-axis. So the actual solution is x equals 4. 4 in the box, 1, -5, 5, -4. You know what? I bet you can finish this. Do your division, do your factoring, do your quadratic formula. Finish this one off, please. Down 1, up 4, down -1, up -4, down 1, up 4, down 0. So this is x minus 4 times x squared minus x plus 1. Clearly x equals 4 is an answer because I already came up with that one. That's how I created my factor. But as for the other piece, I need the quadratic formula. Negative b, 1, plus or minus the square root of b squared minus 4 times a times c all over 2a. 1 plus or minus square root of 1 minus 4 over 2. 1 plus or minus square root of -3, how about I go right to I root 3 over 2. My three answers are 1 plus or minus I root 3 over 2 and 4. Those are my answers. Letter B, how many solutions are there? Okay, we haven't done one of these yet. There are going to be 4 solutions to something like this. Let me get you started. My possible integer solutions, factors of 12, so plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, 6, and 12. I'm going to go and solve by graphing. You should be doing this along with me. X to the 4th, minus 5x to the 3rd, minus x squared plus 20x minus 12. Set my window. I think I should probably change the window so it goes a little bit lower so I can see the bottom, just to make this thing look nicer, I guess. I don't know. I see 4 x-intercepts. Let me try to find them. So actually, here's the logic I'm going to use with this. I want to find 2 integer solutions, because if I find 1, I can divide by that factor and turn my quartic into a cubic. But then I can divide the cubic by the factor that gives a second 1 to turn the cubic into a quadratic, and I can deal with that. So let's see what we can do. My first x-intercept, let's see, a little above, a little below. Oh, that looks good. X equals -2. You keep going and tell me what the other integer solution is, please. Pretty sure this next one is not going to be an integer. Not one of the numbers on my list, probably. Yeah, that's a decimal. Let me try the next one. Let me try this. Oh, that's good. X equals 2 is good. The other one will be a decimal as well. But I found everything I needed. I've got my 2 actual integer solutions. Let me deal with -2. I'm going to divide by x plus 2, the factor that gives me -2 as an answer. 1, -5, -1, 20, -12. And here we go. Down 1, up -2, down -7, up 14, down 13, up -26, down -6, up 12, down 0, which means I have a factor of x plus 2 and a cubic x cubed minus 7x squared plus 13x minus 6. I'm now going to divide again. I'm going to divide this by the factor that gives me 2 as a solution by x minus 2, which means put 2 in the box, divide that cubic, down 1, up 2, down -5, up -10, down 3, up 6, down 0. We've got x plus 2, we've got x minus 2, we've got x squared minus 5x plus 3. Easy, easy, because you already have those solutions anyhow. quadratic formula. Please go finish this off and get your 4 answers. So from this, I'm going to get x equals negative b, 5 plus or minus square root of b squared, 25, minus 4 times 8 times c, all over 2a. 5 plus or minus square root of 25 minus 12 square root of 13 over 2. So my 4 answers, these 2, negative 2, and positive 2. Those are my 4 answers. One last problem. How many solutions in letter C? Should be 5 solutions. All the possible integer solutions are the same as letter B. Can you please take a moment to use the graphing calculator and figure out, let's see, we want 5 solutions. I've got to be able to turn this into a quadratic. So if you find 1, you can divide and turn it into a quartic. If you had a second, you could divide again, turn it into a cubic. And if you had a third, you could divide again, turn the cubic into a quadratic. Find your 3 actual integer solutions. Send those into Edpuzzle. It's a little off the graph, but I think it's good enough for what I need. I only see 3 intercepts, which means the other 2 are probably going to be complex. There, one there. Looks like x equals negative 2 is an actual solution. It's kind of looking like 1, but let me make sure it's not like some random decimal. Yep, x equals 1 is going to be good. And finally, x equals 3. How about you see what you can do? See if you can solve this and send all 5 answers into Edpuzzle. Start with negative 2. So we've got what factor gave us minus 2, x plus 2. We're left with x to the 4th minus 6x cubed plus 13x squared minus 14x plus 6. Let's now divide this thing by x minus 1, 1 in the box. X plus 2, x minus 1, x cubed minus 5x squared plus 8x minus 6 equals 0. Now I'll divide that cubic by the factor that gave me 3 as a solution, by x minus 3. 3 in the box. X plus 2, x minus 1, x minus 3, x squared minus 2x plus 2 equals 0. These are the 3 integer solutions I got. This one's going to require a quadratic formula. Negative b plus or minus square root of b squared is 4 minus 4 times a times c all over 2a. This is 2 plus or minus square root of 4 minus 8 over 2. 2 plus or minus square root of negative 4 over 2. Square root of negative 4 is 2i. 2 plus or minus 2. I'm going to go separate my fraction right away. I am getting 1 plus or minus I. 1 plus I, 1 minus I. I also have negative 2. I also have 1. I also have 3. Those are my 5 solutions. As long as we have some integer solutions, we can solve by first dividing by the factor that gave the integer solution, turning things into a quadratic, and then solving the quadratic. So I guess this is it for Unit 5, and I guess this is it for Term 2. You're going to do a little bit of practice with this that you're going to send in to get your participation credit for today. And beyond that, I guess I will see you in Term 4. Take care.